Okay, so now we did before exponential function. So now there is a logarithm function. So let's see here, logarithm function. Logarithm function. So in a logarithm function, so logarithm function is the inverse function of exponential function. So what is the properties of inverse function of any function? So the properties of inverse function is the function and their inverse are reflection about y is equal to x. So logarithm function we have to represent here. So logarithm function is written as y is equal to log of x to the base a. It is read like that, log of x to the base a, or you can say fx is equal to this. But we have to, this is the representation of logarithm function. So logarithm function is the inverse function of exponential function. So let's see how to find the inverse of exponential function here. So here is y is equal to a to the power x is a exponential function. So how to convert from exponential to logarithm? So it is written like that, y is equal to a to the power x. So we can convert this by solve for x. So x is equal to, it is written as log of y to the base a. Now exponential get converted to logarithm. How? Let's see once again. Y is equal to a to the power x. So this x is equal to log of y to the base a. Exponential have the base a, logarithm has the same base a. Exponential and logarithm both have same base. So now this solve for x, and x and y is the dummy variable. So we can represent this as like that, y is equal to log of x to the base a. So this is called logarithm function. So now how we can represent this in a diagram? Let's see here. There is a diagram, is this is y, this is x. What is the exponential function? So exponential function graph is like that. This is the graph of exponential function. And there is a line, y is equal to x. There is a line, y is equal to x. This is the line, this is called line of reflection. What I said? What is the relation between function and their inverse? Function and the inverse are the reflection about y is equal to x. So how their reflection we can represent here. Here y is equal to x, never touch x-axis, but in the logarithm function never touch y-axis. So their reflection function is like that, like that. So this is called logarithm function. So y, this is y is equal to log of x to the base a. So this is the graph of logarithm function. It crosses through 1. So it is also crosses through 1. This is 0, 1 we can say, this is 1, 0. So in a logarithm function, so what is the domain of the logarithm function? So we can see the domain of the logarithm function is domain of the logarithm function, domain of logarithm function. Domain of logarithm function is always x is greater than 0. X is greater than 0. And what is the range of the logarithm function? The range of the logarithm function is, do never touch. So range is from 0 to 1. Separately we can say that range is all real number. range is all real numbers, but separately you can see from 0 is less than x is less than 1, from value of x from 0 to 1, y is less than 0, and for the value of x is greater than and equal to 1, y is greater than equal to 0. So this is the range of the logarithm function. So now after that, in a logarithm function, this is the graph of logarithm function, and now we have to prove some properties of logarithm functions, called some theorems are there, we will prove. So now some properties of logarithm function, and we have to prove that logarithm function, so their properties. So first, like say theorem is, first theorem is, so this is called product rule. So log of xy product to the base a, any base we can say that, base a is equal to log of x to the base a plus log of y to the base a. So this is the one property, this is called product law. Now we have to prove this property. So for that, let's prove. So let log of x to the base a is equal to y. Now don't say y, suppose p, and log of y to the base a is equal to q. If log of x to the base a is equal to p, so in exponential function, what we understand here, so let's see here, reverse form. Suppose y is equal to a to the power x, then how to convert in the logarithm function? So x is equal to log of y to the base a. Similarly, if we have to convert from logarithm to exponentials, how we can convert? Then we can say this y is equal to this a to the power x, this way. Exponential to logarithm, logarithm to exponential. So here is log of x to the base a is equal to p. So how we can write x? Logarithm to exponential. So x is equal to a to the power p. How to write y? Y is equal to a to the power q. So now, because we have to use the product rule, now we have to multiply x and y. xy is equal to what? A to the power p times a to the power q is equal to a to the power p plus q. Now let's see here, xy is equal to a to the power p plus q. This is in the form of y is equal to a to the power x. This you can say, this y is equal to a to the power x. How we can convert this exponential to logarithm function? Y is equal to a to the power x. So this x is equal to log of y to the base a. So may I write? This is in the place of x. So p plus q is equal to what? P plus q is equal to log of xy to the base a. So now we can see there p plus q is equal to, what is the value of p? What is p? P is log of x to the base a. I will write this first in the left hand side. So log of xy to the base a is equal to p plus q. What is p? Log of x to the base a. Log of x to the base a plus, what is q? Log of y to the base a. So this way we proved that. So this way we can prove one properties, that is the product, that is called product law. So product law, log xy to the base a is equal to log of x to the base a plus log of y to this base a. So this way we can prove this. So now the next theorem, for any positive number a, log x over y to the base a is equal to log of x to the base a minus log of y to the base a. This is called quotient rule. So that we have to prove. Now how to prove that one? Again the same way. To prove is, let log of x to the base a is equal to p and log of y to the base a is equal to q. Then what? As we did before, log of x to the base a is equal to p. So how to write the value of x here? So x is equal to a to the power p and y is equal to a to the power q. So x is equal to a to the power p and y is equal to a to the power q. Now what to do? We have to divide. So now x over y is equal to what is the value of x? A to the power p over a to the power q. So how can we simplify this? May I write a to the power p minus q? Same base, power will be subtracted. So x over y is equal to a to the p minus q. Now let's see once again. This is x a to the power, this is y is equal to the formula like that. Y is equal to a to the power x. How to convert in the logarithm? This x is equal to log of y to the base a. So this is x, this is in the place of x. So p minus q is equal to what? Log of y to the base a. So now this implies, I will write this first, log of x to the over y to the base a is equal to p. What is p? This is equal to p minus q. What is p? P is log of x to the base a. Log of x to the base a minus q, log of y to the base a. So this way we can prove quotient rule. Log of x over y to the base a is equal to log of x to the base a minus log of y to the base a. So this way, this is called quotient rule, the quotient property. While solving logarithm problem, we have to apply this property. So this way we can prove. So another theorem, for any positive number a and x, log of x to the n, log of x to the power n to the base a is equal to n log of x to the base a. The power will go the back of the log x. So this is the properties, the power rule, and how to prove that one. So for that, let's see how to prove. There is let log of x to the base a is equal to, okay, again p. So now what is the value of x? X is equal to a to the power p. But here is x to the power n here. So what to do here? Taking power n both side. Let's taking power n both side. So x to the power n is equal to a to the power p to the power n. So x to the power n can be written as a to the power np. Again, let's see product again. Exponential function. What is the exponential function again? Y is equal to a to the power x. Suppose this whole is y. This is a to the power x. Then x is equal to what? Log of y to the base a. Same thing we have to apply here. So np is equal to log of x to the power n to the base a. So now this I will write this first. So log of x to the power n to the base a is equal to np. And what is our p? P is log of x to the base a. P is log of x to the base a. So this way we can prove this property. Now after that, there is another property. For any positive number a and x, we can say that another theorem is log of x to the base a. Suppose we want to change base, then what to do? Then we can change like that, log of b to the base a times log of x to the base b. This way we can change base. So log of x to the base a, if we want to change, and this way we can change. So this is the another property. So that is the property we have to remember that. So there is a product rule, quotient rule, the power rule, and there is a changing base. So that property we can use to prove the logarithm problem. So now we have to prove this property. So for that proof, let's see here, let log of x to the base p is equal to p. So by definition, what we can write? X is equal to b to the power p. X is equal to b to the power p. So there is another property. Directly we can convert from exponential to logarithm. In the place of that, other way also we can directly by saying that, by taking logarithm both sides. So we have to take log both sides. So if we'll take log both sides, having base a, so taking log both sides. So log, this is by definition we can write. So taking log of x to the base a is equal to log b to the power p to the base a. So now what? So we did before this rule, we have to apply this rule here. So log of x to the base a is equal to p will come back. So there is log of b to the base a. So now log of x to the base a is equal to, what is the value of p here? The p is log of x to the base b times log of b to the base a. So this way we can prove this. How to change? If we have to change the base is a. If we want to change any base, so we can do like that. So log of x to the base a becomes log of b to the base a times log of x to the base b. This way we can change the base of logarithm function. Now another type of function is the new type of function. There is hyperbolic function. Hyperbolic function. How to define hyperbolic function? So hyperbolic function is defined on the basis of exponential function. By combination of exponential function, a function is defined by the combination of exponential function, and that is called hyperbolic function. So to define hyperbolic function, so we have to, their exponential functions play different role there is. So hyperbolic function is the new type of function is found by the use of exponential function. A function by combination of exponential function, by combination of exponential function, new type of function is formed, is called hyperbolic function. Is called hyperbolic function. Let's see here some combination of exponential functions. Now here consider some combination of some exponential function ex and e to the power minus x. What are they? Let's see. The first one is, we can say e to the power x minus e to the minus x over 2. Another type of e to the power x plus e to the minus x over 2. Another type is e to the power x minus e to the minus x over e to the power x plus e to the power minus x. Another type is 2 over e to the power x minus e to the minus x. 5, another type, I will write here. 5, another is 2 over ex plus e to the minus x. 6, another we can say that e to the power x plus e to the minus x over e to the x minus e to the minus x. These are the some combination of exponents ex and e to the minus x on the basis of hyperbolic function is defined. So some hyperbolic functions are sine hyperbolic x. It is written as sine hyperbolic x is equal to e to the power x minus e to the minus x over 2. Another is cos hyperbolic x. Cos hyperbolic x is e to the power x plus e to the power minus x over 2. Another is tan hyperbolic x, that is e to the power x minus e to the minus x over e to the power x plus e to the power minus x. There is cot hyperbolic x is e to the power x plus e to the minus x over e to the power x minus e to the minus x. There is cosec hyperbolic x. Cosec hyperbolic x is 2 over their reciprocal, we know that, e to the x minus e to the minus x, and sec hyperbolic x is equal to 2 over ex plus e to the power minus x. These are the some. So that we said on the definition, hyperbolic function is formed by the help of exponential function, by the combination of exponential function. So these hyperbolic functions are defined on the basis of exponential function. Okay, some identity and formula based on hyperbolic function. Some identities and formula on hyperbolic function. The first is that sine hyperbolic square x, not sine, it will start with the cos, not sine. Cos hyperbolic square x minus sine hyperbolic square x is equal to 1. Normally in trigonometry, cos square x plus sine square x is equal to 1, but here is cos hyperbolic square x minus sine hyperbolic square x is equal to 1. Another is, what is that in the trigonometric function? Tan square x minus sec square x is equal to 1, but here is tan hyperbolic square x plus sec hyperbolic square x is equal to 1. Just little opposite here, but in the case of 3, what is there in the cosec? Cot hyperbolic square minus cosec hyperbolic square is equal to 1. But in this case, in the case of cot hyperbolic square x, here is plus or minus. Here in this case, we have minus cosec hyperbolic square x is equal to 1. Another case is sine, generally sine minus theta is equal to minus sine theta. So here is the same case is there. sine hyperbolic minus x is equal to minus sine hyperbolic x. 5 cos hyperbolic minus x, as the previous rule, there is cos hyperbolic x in a cos hyperbolic x. And now 5 6 another is there, some properties of multiple angle. There is sine hyperbolic 2x is equal to how much? So there is a 2 sine hyperbolic x cos hyperbolic x, like that. And some compound formula is there, 4 5 6 7 sine hyperbolic x plus y is equal to what? Sine hyperbolic x plus y is equal to sine hyperbolic x cos hyperbolic x plus cos hyperbolic x y, cos plus times sine hyperbolic y. So that is the properties in sine. And what happened in the cos? So let's see here in the cos hyperbolic x plus y. Generally in the cos, what happened there is in between there is a minus, but here is no. So there is cos hyperbolic x cos hyperbolic y. In the place of minus there is plus sine hyperbolic x sine hyperbolic y in the case of cos. But in the case of cos minus hyperbolic x minus, there is in the minus there is a plus. In the general identity, trigonometric identity, but here is cos hyperbolic x cos hyperbolic y. If there is minus, so minus sine hyperbolic x sine hyperbolic y. So these are the some formulas and identities we can prove by using exponential function. The definition of cos and sine hyperbolic, we can prove that all formula. So these are the formula that we have to keep in mind. Now let's see the question. There is, we have to prove that cos hyperbolic 2x is equal to 2 cos hyperbolic square x minus 1. So we have to use the formula here. So we have cos hyperbolic 2x is equal to, what is the exponential form of cos hyperbolic x? So e to the power x, in the place of x there is 2x, so 2x plus e to a minus 2x over 2. This is the formula. Now we have to apply little bit, we have to just add and subtract here so that you can understand later. E to the power 2x, I will use here 2 plus e to a minus 2x minus 2. Minus 2 to cancel, then same expression is there, divided by 2. Why I did like that? So let's see here. If you can see, this can be written in the form of perfect square. How? Ex plus e to a minus x whole squared minus 2 over 2. You can see how. So let's see, expand this here. Just here we have to expand this. E to the power x plus e to the power minus x whole square is how much? There is ex whole square plus 2ex times e to the minus x plus e to the minus x whole square. That is e to the power 2x plus e to the x times e to the minus x, e to the power 0 becomes 1. That becomes 2 plus e to the power minus 2x. So let's see, e to the 2x plus 2 plus e to the minus 2x can be written as ex plus e minus x whole square. So this way we can write. Now separate the denominator. So e to the power x plus e to the power minus x whole square over 2 minus 2 over 2 becomes 1. If I want to keep this 2 within the square, under the square, then what to do here? I have to do here 2 multiplied here and ex plus e to the minus x whole square over 4 minus 1. I can write. Then after 2 May I write like that? Then ex plus e to the power minus x over 2 whole square minus 1. Now let's see. 2 times, because if you make their squares, ex plus e minus x whole square, 2a square is 4, the same thing. So you can express this as that way. Now what is the form of ex plus e to the power minus x over 2 is, what is this? This is cos hyperbolic x over 2 times. So this is 2 times cos hyperbolic, because there is square, so square x minus 1. Hence we proved the RHS. So we can take, we have LHS, we can say that. So this is RHS, hence proved. Hence proved. This way we can prove the hyperbolic function. So now we have to, in a logarithm function, we have to prove that log xyq over z squared to the base a is equal to log of x to the base a plus 3 log of y to the base a minus 2 times log of z to the base a. We have to prove that. So let's LHS first. Left hand side. Log xyq over z squared to the base a can be written as. Now we have to apply some properties here. What were first quotient rule? First we have to apply quotient rule. Log of xyq minus log z squared to the base a to the base a. What properties I applied here? So log of x over y to the base a is equal to log of x to the base a minus log of y to the base a. That property I applied here. This is x, this is y. So log of this by this. Now what property we have to apply here? Let's see here. This is product rule. Product rule. So there is log x to the base a plus log y to the power 3 to the base a minus log z squared to the base a. What property I applied here? Product rule. What product rule? Log xy to the base a is equal to log of x to the base a plus log of y to the base a. We can this way I use that property here. Now let's see here, log of x to the base a plus this power rule, 3 will come in the back, 3 log of y to the base a minus 2 will come at the back, 2 log of z to the base a. What property I applied here? Log x to the power n to the base a is equal to n log of x to the base a, any base. So this way, log of x to the base a plus 3 log of y to the base a minus 2 log of z to the base a. So this way we proved RHS, hence proved. Hence proved. So this way we can prove this question. So now let's see, prove that a to the log of x to the base a is equal to 1. We have to prove. This is a property. Here we have to prove, but we have to keep in mind to apply somewhere to use logarithm. So a to the log of x to the base a, how we can say that? That becomes 1. So now for that, to prove LHS, you can say that, or just proof, we can say that proof. Proof is, let log of x to the base a is equal to p. So how we can write? X is equal to a to the power p. So now there is log of x to the base a. So log of x to the base a is equal to, I supposed p here. So x is equal to a to the power p. Now to prove that log of x to the base a is equal it's equal to x. That's the wrong question. So prove that log of x to the base a is equal to x. We have to prove x, not 1. So a to the log of x to the base, and this base is same, so directly we can write x. So we have to correct this. So before I wrote 1, so that's mistake. So log of a to a log of x to the base a becomes x. So log of x to the base a is equal to p, then x is equal to a to the power p. So now let's see. So directly we proved here. So x is equal to a, and what is our p? So p is log of x to the base a. P is log of x to the base a. We can write in the left hand side, log of x to the base a to the power log of x is equal to x. So this way, this is the way of we can show that a to the log of x to a is equal to x. But these are the properties we have to apply in some other place, so you have to keep in mind. This is just like a formula or properties. So there is another question. We have to prove x to the log of y minus log of z, y to the power log of z minus log of x, z to the power log of x minus log of y is equal to 1. We have to prove that. So let's take left hand side. So there is, so left hand side is this. So first of all we have to let log of x, log x is equal to a. So let it be clear, if anywhere there is written only log, it means their base is 10. Normally, if other than 10, we have to write here. If we have to write any other base, we must represent here. But only if log is written, it means their base is 10. That we have to understand. So log of x to the base 10 is a. Now let log of y to the base 10. Base 10 is understood. We don't need to represent. We don't need to write. So log of y to the base 10. So log y is equal to b. Log z is equal to c. So log of x to the base 10 is equal to a. So how can we write x? While we learn from exponential to logarithm to exponential, we can write x is equal to 10 to the power a. Similarly, y is equal to 10 to the power b. Similarly, z is equal to 10 to the power c. So now come to the point. Now replace in LHS. So there is x, first write x, log y. What is log y? Log y is b. That is b minus log z is c. So c times y to the power. What is log z? Log z is c. So c minus, what is log x? Log x is a. C minus a times z to the power. What is log x? Log x is a minus, what is log y? Log y is b. Now let's see. So a to the, now what is x? Now replace the value of x here. X is 10 to the power a. In the place of x, if I will write 10 to the power a to the power b minus c, here is also 10 to the power b to the power c minus a times z is 10 to the power c to the power a minus b. Now what will happen? Law of indices says that, what is the law of indices? A to the power m to the power n becomes a to the power mn. This is the law of indices. That, so a get multiplied with the b minus c. That becomes 10 to the power ab minus ac times 10 to the power bc minus ab. Here 10 to the power AC minus BC. Now same base, power will be added. So AB minus AC plus BC minus AB plus AC minus BC. So AB cancel, AC get cancel, BC and BC cancel. That becomes 10 to the power 0 is equal to 1. So this way we proved that, hence proved. So this way we prove that one. Now let's see another question. If log x over y minus z is equal to log y over z minus x is equal to log z over x minus y, if that condition is given, then we have to prove that one. So let's see, these are in the proportion. So first of all, we have solution log x over y minus z log y over z minus x is equal to log z over x minus y is equal to some value constant, we can k, we can say that this is say means हामीले भनेको केही एउटा सपोज गरिदिएको is equal to k. So this is equal to also k, that is equal to also k, that is equal to also k. So what we can write? So if that is equal to k, log x over y minus z is equal to k. So what is the value of log x? Then log x is equal to k times y minus z. What is the value of log y? Log y is equal to k times z minus x. What is the value of log z? Log z is equal to k times x minus y. Log x is equal to this. We know that if log, what is their base? The base is 10. So log x is equal to this. So what we can write? X is equal to 10 to the power, this x is equal to 10 to the power k times y minus z. This y is equal to 10 to the power k times z minus x. And this z is equal to 10 to the power k times x minus y. Now we have to replace, now take LHS. LHS is this, x to the power x, y to y, z towards z is equal to, this place of x is replaced by that one first. This x is replaced by 10 to the power k times y minus z to the power x. So k times this to the power that one, and there this x get multiplied. So directly we can say that, okay, 10 times y minus z times x times 10 to the power k times z minus x times y times 10 to the power k times x minus y times z. Let's see here. This x is replaced by that one. This y is replaced by that one. This power x, their power x is here. This y is here. This z is here. So I am not changing these values. So now let's see here. So what will happen? Same base, so power will be added. Make only one base. This plus that. So we have to take k common here. If we take k common, so what is remaining there? Yx, xy minus zx plus zy minus xy plus xz minus xy. Let's see what happened. xy cancel, xzx cancel, zy cancel. So this is 10 to the power k times 0 becomes 0 is equal to 1. So this way we proved that that is equal to 1. Hence, so this way almost all on the basis of the properties of logarithm function we proved. Some of the question we proved here.